Hello and welcome to Math Around Us, the platform where concepts of math come out of the books into the real life so that you can experience that how math actually rule the real world. So if you like the video, then don't forget to hit the like button, share it with your friends, and if you're new to this channel, don't forget to subscribe or follow the channel. Friends, today we are going to talk about the mathematical concept that is repeating itself in the nature and is used by the scientists to predict upcoming solar or the lunar eclipse, moreover many more orbital cycles. So let's decode the topic today and we are going to talk about LCM. Yes, right. So this is nothing but the LCM. LCM is widely used. We all know how to find out the LCM of two or three number. That is the common multiple. But why it is the least one, that we are going to talk about. Okay. And what are the multiples of a number? Okay. That we are also going to talk about, and how it is used by the scientists to find out the next orbital cycle. Okay. Or when the two satellites that are revolving around the earth, okay, in the same direction or the different directions will meet again at the same point where the first, suppose they are seen in 2026 when they will meet again at the same point. So this is all where LCM is widely used. What you have to do, you have to keep the patience because we are going to start from the very basic multiple. What is the meaning of a multiple? So let's get started from here. Suppose if I take a number 6 over here, any random number, I can take any other number also, but generally I'm going to start from the 6. What are the multiples of 6? That means a number that comes in the table of 6 or that are divisible by the 6. Hmm, this is the meaning of multiple. So whatever comes in the table of 6, I'm going to write it down over here. Okay. And so on. Can you tell me how many multiples does a number have? Any idea? How many multiples does a number have? Okay, in the table of 6 is that is 6 times 6 is equal, 6 times 10 is equal to 60. This is the last multiple of 6. No, any other? What about 66? Yes? Come on. Suppose if I write the table of 6 over here, okay, and this is going to be 54 and 66 and so on, so on, so on. How many multiples? Infinite. Because the natural numbers are infinite. Whenever you find out any natural number that is the biggest natural number, suppose this, okay, I'll say, okay, just add one after it. This is also a natural number and much more bigger than this. So multiples are infinite. So is the case over here. Okay. Now let's take another number. I'm going to take 8 over here. Okay. Now I will write the multiples of the 8. Okay. How many multiples of 8 also? Infinite. Infinite multiples. Now for the common, at least two numbers are required, because if we have to compare numbers or we have to find out the common, then at least two numbers are required. So let's talk about 6 and 8. What are the common numbers over here? We are going to start. Okay. So I see 24 in both of the series. Okay. So this is the first number that is common. Now, if I move forward, the next number that is common over here is 48. That is also common. Okay. And so on. Can you tell me the biggest number? Okay. Biggest number that is common between 6 and 8? Any biggest number that is in your mind that is common? Not possible. Okay. Not possible. We cannot tell the biggest number that is common between 6 and 8. So what we can tell? The least number that is common is the first number that is common between 6 and 8 or any two or three numbers. That's why it is known as the least common multiple. Got it or not? Let's have one example over here, and then we are going to move or shift this idea to the universe. Okay. All right. Let's have it over here. Riva and the Shikha are driving around the circular track. If Riva takes 12 minutes to complete one round, that means the same track is here. Suppose if I take a track over here, this is a circular track. So what Riva is doing, Riva is taking 12 minutes, okay, to complete. Suppose they're starting from this point. I just mark it like this. This is the entry point of the circular track. They start from this point. So Riva is taking 12 minutes to complete one round. Okay. All right. Now, how much time another person is taking? Shikha is taking 10 minutes. That means she is taking lesser time to complete the same track over here. Okay. All right. Now we have to find out that at how much time they will meet again at the starting point. Okay. Suppose Riva is taking 12 minutes to complete this round. Okay. Somewhere over here, they will meet again. Okay, because suppose this is only uh, 10 minutes. Okay, so Riva is going to reach over at this point. Okay, Shikha is going to reach it over this point, and Riva is still somewhere at the back. That means at somewhere over here they will meet with each other. Okay, but this is not the starting point. Okay, they will meet somewhere over here also, of course, because they are revolving around the same track, so they will meet. It's obvious that they will meet, but not at the starting point. They have to meet at the starting point again. Then how to find out? Okay, so what we will do over here is that we will write the multiples of 12. Okay, so I'm just going to write the multiples of 12. I'm going to write the multiples of the 10. Okay, so and so on. These are the multiples of the 12. What about the multiples of 10? 10, 20, 30, 60, and so on. Can you guess the common number over here? Yes, 60. That means after 60 minutes, because Riva is coming at starting point in the first 12 minutes. Then after at 24th minute, she will be again at the starting point. At 36 minutes, she will be again at the starting point. At 48, she will be again at the starting point. And they both are meeting somewhere over here. Over here, they are passing each other. Actually, Shikha is passing Riva every single time because she is faster. Okay, but when they are going to meet at this point again, that we need to find out at the starting point. They will meet in between, but the starting point is something else. Okay, so at 60th minute means after 1 hour, they will meet with each other at the starting point. Means at that time, the entry point, okay, this entry point, okay, Shikha and Riva and the entry point, they all will come together in one single line. Now, can you observe something over here? Yes. When it comes to the solar eclipse or the lunar eclipse, I'm going to talk about that. Suppose this is a sun, you can imagine it. This is the circular or the elliptical orbit of the Earth. Earth is moving around the sun like this in this path. Okay. Suppose we take this path. Okay. Moon is also revolving around the sun. If Earth is over here, then moon is somewhere over here. But when sun, moon, and earth all come together into the single line, okay, at that time we have solar or the lunar eclipse. So suppose this is the sun, this is the orbit, this is the earth, okay, and moon comes over here. Or this is the earth, moon comes over here. So in this case, we are not able to see the moon. In this case, we are not able to see the sun. This makes them aligned in one single line. So we have solar or the lunar eclipse. How scientists predict it? They use the LCM concept. They take the speed of Earth, okay? They take the speed of moon, okay? Speed of Earth, speed of moon, and then they find out when they will have the common number. At that day, at that places, we will be able to see the solar or the lunar eclipse. Have you heard about this concept before? Even scientists use it to find out when the two satellites that are revolving around the Earth will again meet or cross or in line with each other. Suppose one satellite is of NASA, okay, so it is revolving towards in this direction. One satellite is of suppose China or the Russia, okay, it is moving at the more faster speed. Okay, so when the time will come, again they will meet with each other in a single line at the starting point. The starting point where they were observed for. Suppose we have observed two satellites in a single line in the direction of Earth. Okay, two satellites in 2026. Now scientists will use the speed method over here and the LCM method to calculate what the next multiple that is common between the speeds of both the satellites. So they will be observed as aligned in the single line at the starting point. Okay, starting point is very much necessary. At the starting point, when they will be in the same line all together at the starting point. So this is the concept of LCM. So, and we all know that it's very easy for us to find out the LCM of the two numbers. Okay, suppose we are provided with two numbers and we have to find out the LCM of suppose 35 and 40. Suppose if I take two numbers. So we use this method. Okay. Uh, how we are going to use it? There are two different methods to find out the LCM. I'm going to discuss about this method over here. So I will divide it with 5. So if they both are divisible, I will be writing it. So 5 sevens are and 5 eights are. Okay. Now this is a prime number. Okay, that means it is divisible by itself only. So this will remain 7, this will become 4, this will be 2, this will become 7, and this is 2. Now no need to divide. So all together from here to here, write it like 7 times 2 from the last to the top. Okay, over here 7 times 2 times 2 times 5. So this is the LCM, and if we multiply it over here, we will get 280. So we can frame a question like this. It's very easy that now for you also, that if there are two cars, or yeah, two cars that are racing around a circular track, and one takes 35 minutes to complete one round around this circular track, and one takes 40 minutes. One is taking much little more time to complete one round. So when these both the cars will meet with each other at the starting point, in just at the same point where they started, so it will be 280th minute when they will come together at the same point from where they started. So this is how the LCM is used in the real life application. In the next video, we are going to talk about the different methods to find out the LCM, and that are easy methods, much more easier method than this to find out the LCM of two or more numbers. So don't forget to watch that video also. And if you like the concept over here, that how we are using LCM in the real life, you can share it with your friends so that they are also getting to know, wow, this is how LCM is working. Thank you for watching. Bye. Take care.